Okay, so I want to take a look at the graph of the polynomial x to the third plus 2x squared minus x minus 2. Okay, and I just want to show you how to finish this off. So we're on the step. We've already calculated, we've figured out the end behavior, which is going to be important when we finish this graph off. We've got the x-intercepts, we figured out the y-intercept. So we're on the first step, where we're trying to kind of estimate the turning points. Now, because we're doing this by hand, this doesn't have to be completely accurate. Again, we're kind of just trying to look at the graph to see some characteristics, see some behavioral things there. So we don't have to be spot on. Okay, so we're just going to kind of estimate that. All right. So usually when you graph a polynomial function, the turning point's going to be roughly halfway between the x-intercepts. It isn't exactly, and this isn't a fact, but usually that's a good place to estimate. Again, we're just trying to take a look at the behavior of it. Okay. So what I'm going to do is look at the x-intercepts, x equals negative 2 and x equals negative 1. I'm going to pick a point halfway between that to figure out, again, what the graph is going to do, what the behavior of it is. So I'm going to pick x equals negative 3 halves. I'm going to evaluate the function at x equals negative 3 halves. So let's go ahead and do that. Okay. So we're going to do negative 3 halves to the third plus 2 times negative 3 halves squared minus negative 3 halves, okay, and then plus 2. Now I'm going to kind of skip the math here. I'll let you evaluate this on your own, but you should come out with, if you evaluate the function of negative 3 halves, this should come out to 5/8. So that means when x equals negative 3 halves, the y-coordinate is 5/8. Okay, I'm going to go ahead and plot that point roughly. Okay, so negative 3 halves, again, we're about halfway between negative 1 and negative 2. And then we go up a little bit past halfway, but not to 1. I'm going to kind of plot that point here. Okay, now let's go ahead and graph this. Okay, now when you graph this function, again, remember the end behavior because of our leading coefficient test, okay, and that the degree is odd. We know that it's going to fall to the left, so it is falling to the left here. Okay, as I draw the graph. All right, so it's going to come up from the left, really, since it falls to the left. Comes up, hits the first x-intercept. Then roughly around that point that we just found, it's going to turn. Comes through the second x-intercept. Okay. Now normally what we would do is we would find a point halfway between our other two x-intercepts. Now we know there's going to be 2 turning points because the degree is 3. Okay, so it's going to turn twice. Normally we'd find something roughly halfway between these 2 x-intercepts of negative 1 and 1. Okay. Well, we've already got a point. Just happens to be our y-intercept. That's about halfway between. So it's a good bet that our graph is going to turn right around there. And then it's going to come up through the final one and then finish off. And I'll draw arrows to denote that it's going forever in those directions. Okay? So that's a good way to finish it off. And again, if it doesn't have to be exact. I know that those points aren't exactly on the graph, but again, it's really just important to know the behavior of it. Okay? So we've got the end behavior. We see the turning points. So we can just roughly estimate the turning points. But this is roughly the graph of x to the third plus 2x squared minus x minus 2.